Okay, before we start discussing the new materials, let's review a little bit about what we learned yesterday. Okay? Who can tell me something about yesterday? I know it's a terribly long time to remember all the way back when, but who can tell me something about yesterday? Ariel? Cannizzaro found a standard for the relative mass of an atom. Okay, good. Alex, what's something else? Who was that? Mendeleev. Mendeleev heard about those atomic masses, and he constructed his own periodic table based on those masses. What else, Max?
Henry Moseley and Ernest Rutherford found the laws of reacting.
Okay. Henry Moseley, who was working with who? Ernest Rutherford, found a different method to group the periodic table. How was that? How did Moseley group his periodic table? Based on what?
Increasing number of protons.
The increasing number of protons, the atomic number. Okay? Mendeleev based his on the masses. Moseley based his on the atomic number. Remember, Moseley was working with Ernest Rutherford. What was Ernest Rutherford noted for? The gold foil experiment, which helped us find the nucleus. Okay? So those are some reviews of ideas we learned yesterday. Now, today, we are going to go further in depth. You've learned about things that we've called the S, the P, the D, and the F. What were those? S, P, D, F. The shapes and types of the orbitals. Okay, we also said they were sublevels. All right. So we're going to go more in depth. By the time you're done today, you should tell me a little bit more about the SP, the D, and the F. You should be able to. Now, you've already got this slide. So let's check out this one. Okay. Electron configuration in the periodic table. We've talked about the electron configuration. We've done some of them. Today we're going to go in depth a little bit more and talk about the different areas. We know that this green area over here signifies the S's. We know that this kind of reddish area here is the P block. The yellow ones here are the D's, and down at the bottom of the table are the F's. So we know where they are. Let's learn a little bit about them. And we're going to start off with the S block, groups 1 and 2. The elements of the S block are chemically reactive metals. The group 1 metals are more reactive than the group 2 metals. This is because the outermost energy level of an atom of a group 1 element contains only one S electron. This group, group 1, is known as the alkali metals. So the alkali metals have only one S electron on their outermost energy level. That is why they are more reactive. What you're going to see later on when we talk about bonding is that these group 1 elements like to give away an electron, thus becoming a positive charge, which we call a cation. But that will be discussed later in bonding. These are some properties of the alkali metals. Once you get those down, we'll talk about them, and then we'll watch that video. Alkali metals have a silvery appearance and are soft enough to cut with a knife. You're going to see this on the video. It's almost like a warm stick of butter. Okay, very easily the knife will pass through that metal. Alkali metals are not found in nature as free elements. This is because they are so reactive. You'll also see on this video how the guy, when he cuts that alkali metal, immediately you can see the changes occurring in it just by reacting with the air. They react strongly with water to produce hydrogen gas and aqueous solutions of a substance we know as an alkali. Now, do you remember the video I showed you the other day where they put the sodium in the water and it swirled around and all of a sudden it became a fireball? Okay? That was this strong reaction with water. And the fireball was probably when this hydrogen gas here ignited. So let me pull up this video, hopefully, and we'll see what's going on.
There are 6 alkali.
No.
There are 6 alkali.
No, I want to make you bigger.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become covalent compounds that form on the metal.
See it becoming now, I want to say, less shiny.
When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water in the same way. Let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a light flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our 5th alkali metal.
Now, that last one there was a pretty violent reaction, enough that that glass container shattered. And that wasn't even the bottom one of the group. Francium's the bottom one of the group. But do you notice how when he dropped it in there that he had a big glove on? So he knew that there was going to be something happening there, and it ended up smashing and breaking the glass. So we can say that, yes, they react very strongly with water. The second group on the S block is known as the alkaline earth metals. These metals contain a pair of electrons in their outermost S sublevel. So the alkaline earth metals have two S orbital electrons. They are harder, denser, and stronger than the alkali metals, and they have higher melting points than the alkali metals. They are less reactive than the alkali metals, but they are still too reactive to be found free in nature. So if you look, beryllium, magnesium, calcium, strontium, barium, radium, okay, you go down that row, you're not going to walk out and say, oh, here's a chunk of calcium, because it reacts in nature also, so that it will not be strictly calcium. It'll be combined in a compound. The D block. Okay, and you'll often hear me talk about numbers. On your periodic table, look at the numbers above the D block. They range from 3 to 12. 3 to 12. I tend to use those numbers more than the Roman numeral numbers when I am discussing these elements. So 3 through 12 are the D block in yellow up here. What do we know about the D block? They are metals that we refer to as the transition elements, or more commonly, the transition metals. The transition elements are good conductors of electricity, and they have a high luster. They are very shiny. They are less reactive than the group 1 alkali metals and the group 2 alkaline earth metals. Palladium, platinum, gold are some of the least reactive of all metals. But what can you say about those three metals? At least platinum and gold. They're the more expensive metals. Okay, I guess I didn't realize this, but you go through and you look at jewelry that's made of platinum, it's even more expensive than jewelry that's made of gold. I didn't realize that. I thought gold would be more expensive, but actually the platinum is, if you look that up. The P block of elements, groups number 13 through 18. 13 through 18. Now this diagram's just showing you the S block and the P block. Okay? Together we call the S block and the P block the main group elements, also known as representative particles. So if you hear me talking about a main group element, I'll be talking about an element that's either in the S block or the P block, the main group elements. Now, some of these have their own special names. For instance, we call group 17 the halogens. The halogens are the most reactive of the nonmetals. They react vigorously with most metals to form what we call salts. What we call salts. So you're going to see later on when we discuss this that these metals combining with metals are all referred to as salt. Now, when we think of salt, we think of table salt, sodium chloride. Okay? That is an example of a salt, but literally anytime we have a cation mixing with an anion, we classify it as a salt. We've talked a little bit about the F block of elements. We talked a little bit about the F block of elements. These elements in the F block are wedged between groups 3 and 4 in the 6th and 7th period. The lanthanide series, the lanthanides are shiny metals similar in reactivity to the alkaline earth metals. So that would tell me that they're very reactive, because we said that the alkaline earth metals are very reactive. The actinides are all radioactive. The first 4 on the table, the first 4 actinides, are the only ones that are found naturally. All the other actinides are made in laboratories by scientists. So they are man-made elements. So, I guess the biggest thing that we've done today is we've talked about the S, the P, the D, and the F, and we've given some names to these particular areas. Now, I stated earlier, we talked about the P block. Let's look at some of the diversity. Take out your periodic table. Let's look at some of the diversity that P block shows, because that is where we've got the stair step, right? We have the stair step in the P block. So we know that we have nonmetals there. Typically, the ones that are touching the stair steps are what? They're what? Metalloids, excellent. The ones touching the stair step are metalloids. And you're going to see even down at the bottom, okay? Even down at the bottom, we have metals. Because I see tin down there. I see lead down there. Those are both metals. So that P block is a very diverse group, okay? Now, if you look at that P block, we said that group 17 we call the halogens. What did we call group 18 the other day? The noble gases. Sometimes you will also hear it called the inert gases. Okay? Those guys don't want to react with anything. Okay? The noble gases do not want to react. As for the other ones in the P block, we often call them as just what their top element is. The carbon family, the nitrogen family, the oxygen family. So we often refer to those as just the families of the top element. Now,